A.L.M. Today we are going to deal with wastages on foundation. Introduction. Foundation designs and performance depend on two factors: the nature of the ground on which they are placed and the load of the structure. The foundation design caters to the requirement of the weight of the structure, which is known as dead load, and the other weight, such as other personal and furniture, etc., which is known as live load. The possibilities of unnecessary wastage on there are unnecessary wastage on foundation. There are always possibilities for unnecessary wastage on foundations. This is a job for a structural engineer. A site visit will come first. Example: are there neighboring houses showing somewhat cracks, or they are rolling sand? Both may be an indication of subsidence caused by ground condition. Sagging roof lines would also indicate spreading walls or the weakness of roof members. Trial loads give more detailed information on the site conditions. Foundation types. Slip. The most common type of foundation for Irish built cell builds. It consists of a slip of concrete laid in a shallow trench forming a stable base for each wall element. It can be used for both lightweight and heavyweight buildings where the soil is uniformly firm and deep. For a lightweight building, which have a firm layer over a soft layer. Minimum depth according to NI building regulation, for example, is 450 millimeters, which is required to avoid the adverse effect of thrust. Then raft. This type of foundation spread the load over a bigger area of the ground and is more expensive to form than a slip footing because it is a slab of the reinforced concrete the size of the house footprint. The slab is deepest immediately under the outer walls and the edge of the beams. The load-bearing internal walls, cross beams, the steel reinforcement for edge beams and cross beams are often pre-fabricated and drifted in position. Mostly used in cases where the soil type is uniform across the soil and consists of either deep or subsoil or field soil, which is holding water. Where very wide slip foundation would be required, it can sometimes be more economical to use a raft instead. Pipes. These are concrete columns sunk deep into the ground to support the foundation. Specialist contractors drive them into the ground in sections, or they may use steel tubes later filled with concrete as an alternative. Either way, the pipes are located to an engineering design and are very common in field or soft ground. A mini piling service is normally sufficient for houses, with some companies offering a complete subfloor system. A T-shaped concrete beams support the subfloor slab, with the beams in turn being supported by the pipes. Concrete is poured between the beams, forming raft-like slab, and the subfloor is ready for floor trades. The system is engineered to suit the specific house and is ideal for field ground. A third system is to that the above also involves precast concrete planks placed on beams to form a subfloor. This is quicker to install but may be more expensive. Parts and beams. When piling isn't possible, concrete pads can be poured to support the cross beams. They are tied together by steel reinforcing to prevent movement. They, they are made on site from concrete poured into temporary forms. Eco foundation, rubble trenches, we commonly associated with our old stone wall structure, but it was also popularized by architects such as Frank Lloyd Wright. The construction was usually of a shallow trench built with the rubble, which may or may not have been cemented with the basic mortar such as clay and lime mix. More sophisticated foundation would use a rubble built between the stone facing, similar to drywall but in strength. Nowadays, these type of foundations are increasingly being used where the light eco structure is to be built, such as ramming earth walls or stubble and timber walls. The rubble trenches can also be drained out to a sock to improve the site drainage and maintain a dry void under the suspended floors. Since the rubble is expensive, it's essentially flexible to some degree. Some care must be taken to ensure that either the structure can absorb a bit of movement or that the foundation is suitably compacted and load tested for the avoidance of differential settlement. The technique is generally regarded as unsuitable for bearing or soft or expensive soils. Heavy wastage on foundations. Heavy wastage on foundation construction have come to light owing to various reasons. There is no doubt that the foundation has to be designed properly for the suitability of the whole structure. It is also a place for foul play. When there are excess requirements and the same are very so easier to escape. In one contract, it was noted that the consultant passed his duty of design to the contractor. The contractor accepted same without additional cost. The contractor designed the foundation to carry 3 times the proposed load of the building. While constructing, he used the reinforcement as per requirement, thus keeping the employer as he did not give any savings. Lack of communication with the professionals has the potential to increase the foundation cost. In one project, the employer representative noted that the raft foundation of building was designed much more deeper than the similar adjoining buildings. On inquiry, the structural engineer explained that the car park on the top of the floor is in the corner, thus creating a much more bending moment. The employee representative then asked the structural engineer, suppose if we shift the parking to the center of the building, then what happens? The engineer replied that the raft foundation need not be that deep, resulting in considerable savings. The employee representative told the structural engineer to discuss same with the architect and change the car parking to the center of the building, which was finally done. This is an indication that lack of communication between the team members can result in unnecessary cost of the foundations. The other factor that increases the foundation cost is a safety factor used in design. Although there is a requirement of a safety factor, there is no international standard as to what safety factor to be used for a particular case. Common safety factors of 7, 9, 10 and even 12 are used, whereas according to some experts, 2 to 3 can be the norm. There is no question of cutting corners when it comes to foundation of a structure, but another wastage should be eliminated. Maximum limit of volume of seal in concrete. Usually no deductions are made for volume of reinforcement in the measurement of concrete in a remeasure contract. The understanding is that the volume of steel reinforcement in relation to concrete is very small. In multi-story buildings, heavy and in sometimes over reinforcements are used. This may require a revisit regarding the deduction of reinforcement in concrete works. In one instance, the structure was over-reinforced and the building collapsed. The subsequent investigation led to the finding that the structure was over-reinforced to the extent that the concrete did not reach all places, which created the voids, which weakened the structure, resulting in collapse of the building. Therefore, there is a necessity to have the maximum limit of volume of steel in relation to concrete volume, both for strength of the structure and for the reduction of reinforcement volume. If the ratio exceeds a certain amount, civil engineering standard method of measurement, system formula 7.85 ton per cubic meter of steel is widely used in the calculation of the weight of the reinforcement of steel. The same can be used if it is decided to deduct the void for reinforcement in concrete. Thank you.